These are notes for section 6.1. It's a review video over the 5 properties that we have discussed in this section so far. And the first property that we came across was the product property, and that is if you multiply by the same base, multiply x to the third times x to the fourth, the same base, x times x, what we can do is add the exponent. So if you multiply by the same base, add the exponents. So in shorthand, if you multiply by same base, add the exponents. That was the first rule that we picked up in section 6.1. The second rule that we came across was power to a power. And that is if you have a power like x to the fifth, we have the power of 5 raised to another power, x to the fifth to the third, a power to a power. When you have a power to a power, we can multiply the exponents. That would be x to the 15th. So to put that in words, if you have a power to a power, multiply the exponents. Multiply, not multiply the exponents. The next rule we have is essentially the same as the rule that we just went over. If you have the power of a product, so let's say I had x to the fifth, just like the previous problem, y squared. So I have 2 powers in here raised to the third. Well, it's essentially the same rule. I multiply all of the exponents. So that'd be x to the 15th, y to the 6th. So it's essentially the same exact rule. If you have a power to a powers, you multiply all the exponents. So it's essentially the same rule there. When you have a power to a power, we multiply all of the exponents. So even though there's 3 rules, it's kind of like 2. The next rule that we picked up, or property, was the quotient property. And that is if we had something like x to the 8th divided by x to the 3rd. X to the 8th divided by x to the 3rd. And the rule is if we divide by the same base, we can subtract the exponents. If we divide by the same base, so divide by same base, subtract the exponents. So the quotient property and product property are kind of like cousins, brothers, sisters, whatever. They are related in that if you multiply by the same base, we add. If you divide by the same base, you subtract. And then again, our last rule, the power of a quotient, is basically these 3 rules here are essentially the same rule. And that is if you have powers on the inside of a quotient or a fraction of the parentheses. For example, x to the 3rd y squared divided by z to the 4th, all of these powers raised to the 5th. Well, it's essentially the same rule. I take this exponent on the outside and I multiply all of the exponents on the inside. X to the 15th, y to the 10th, divided by z to the 20th. I multiply all of the powers. So if you have a power raised to a powers, again, plural, it doesn't matter if it's 1 or more, we can multiply all the exponents. So those are a quick recap of the previous 4 videos. Now, I am missing the idea of negatives, but that's not really a property. That's just understanding how negatives operate. 2 negatives when you multiply make it a positive. And again, if we look at the power of a power or power to a power, power of a product, and the power of a quotient, those are essentially the same rule applied basically the same way. So let's look at a couple of examples together. On number 1, if you have multiplied by the same base, add the exponents. Power to a power, multiply the exponents. Powers to a power, multiply the exponents. A lot of kids are going to write 8. It's not 8, it's 2 to the 4th. I'm not multiplying 2 times 4. The exponent on the 2 is a 1, so it's 2 to the 4th, a to the 8th, b to the 24th. Divide by the same base, subtract the exponents. Again, I'm just going through the properties that we reviewed over the last 4 days or 4 videos. Again, when you have power raised to a power, you multiply the exponent. That's 4 to the third, x to the ninth. I multiply all the exponents. Here's a problem with negatives, and we need to understand how many negative signs there are in number 6. There's one negative sign here, because it doesn't belong to the 3, but there's 5 negative signs here. So there's 1 here and 5 negative signs because of that exponent. So there are 6 negative signs total, which makes my answer positive y to the 8th. Multiply by the same base, add the exponents. Again, power to a power we multiply, x to the 20th, and the negative belongs to the 4, which means there are 4 negative signs, which makes my answer positive. On number 8, that would be 3 to the 6th, x to the 12th. I take the exponent and I multiply, and I have 3 negative signs, which makes my answer negative. And last here at the bottom, I have 1 negative sign here. I have 2 negative signs here, which makes a total of 3 negative signs. So I know before I do the problem, my answer is negative. And if you divide by the same base, you can subtract the exponents. So negative 3 squared, or you could call that negative 9. Either will work. Powers to a power, multiply all the exponents. That's 2 to the third, y to the 6th, over a to the 6th. That's an a. And I have 3 negative signs, which makes my answer negative. Multiply by the same base, add the exponents, x to the 6th. Multiply by the same base, add the exponents. That's a to the 5th. And I have 1 negative sign here, 1 negative sign here. 2 total negative signs makes my answer positive. Hopefully that helps. See you on the next one.